Question number 1. Complete the table and graph. Y equals x squared minus 3. The first thing that I'm going to do before I even try to graph it or complete the table is figure out what the picture should look like when I'm done. So if I look at y equals x squared minus 3 and I look at the posters that we have in the room, I notice that it's a squared, so it's going to be a member of the quadratic family. And since it's a member of the quadratic family, I know that all the members of the quadratic family have U as a shape. So that's what I'm going to focus on. So I know when I'm done, my graph should be a U. If it's not, then I know that I did something wrong. Okay, when x equals negative 3, we're going to plug this in here. So we're going to do negative 3 squared. Negative 3 squared means negative 3 times negative 3, which is 9. And then we'll subtract 3, and we get 6. And then when we plug in negative 2 squared means negative 2 times negative 2, which is 4, minus 3, which is 1. And then negative 1 squared means negative 1 times negative 1, which is 1, minus 3 is negative 2. And then if I plug in 0, 0 squared is 0, minus 3 is negative 3. And then if I plug in 1, 1 squared is 1, minus 3 is negative 2. And then 2 squared is 4, minus 3 is 1. And then 3 squared is 9, minus 3 is 6. So now we're ready to go ahead and graph it. I think I'll try to put that more in the middle there. Okay, so when I go to graph it, since I'm going to do negative 3, 6, I'm going to go to the left 3 and up 6 and put a point. And then I'm going to graph to the left 2 and up 1. And then I'm going to go to the left 1 and down 2. And then 0, negative 3, which means stay put, and go down 3. And then go to the right 1 and down 2. And then I'm going to go to the right 2 and up 1. And then I'm going to go to the right 3 and up 6. Okay, and hopefully you can see that I did get a U shape, so now I'm just going to go ahead and connect it. And voila, there we go. I got the U shape like I was supposed to. Okay, problem number 2, what is a function? Do the following represent functions or not? Explain why or why not to receive full credit for each problem. So our answer will be a yes or no, and then we will explain. All right, the first one, if I'm looking at a table, does every input have an output? Yes, every item is associated with a price. And then I just want to make sure, does 1 only have one price? Yep, it's only $12. 2 is only 16, 3 is only 12, and 4 is only 16. So even though item 1 and item 3 are both $12, that's okay, because if we think about the dollar menu, that does exist. So this is yes, and my reasoning is going to be that every input has exactly one output. One thing just to show that if this was not a function, if I added to my table like 2, 10, notice then that 2 has 2 different prices, and that would not work. Okay. All right, y equals 3 over x. If we can find a function family that this belongs to, then it's automatically going to be a function. And if we look at the posters in the room, it actually belongs to the inverse function family. So I'm going to say yes, it is a function because it is a member of the inverse family. Okay, the next one, if I'm looking at this as a function or not, it kind of looks like an absolute value graph, but it's turned on its side, so I'm going to use a vertical line test for this one. So if I draw a vertical line, or any vertical lines, notice the vertical line passes through that picture 2 times. It's only allowed to cross through it 1 time, so this is not a function. And I could say that inputs have 2 outputs, and they're only allowed to have 1 output. And we could say does not pass the vertical line test. Okay, the next one, a teacher makes a table that lists the birthday X and the name of the student Y with that birthday in the class. I always like to make a table for these ones. So X is the birthday. So let's say I'm going to pick mine September 7, and I'm going to put Mrs. Wiersma. Okay, and the name of the student was Y. Well, I guess my name is Mrs. Wiersma. Okay, and then I might put May 18, and that birthday would be Justin. Okay, and I might put October 28, and that name would be Kyle. Now I want to think, is there any way, if I listed September 7 again, would it be possible for me to put another name? Well, yes, I know that there's Jasmine, had her birthday on September 7. So notice September 7 has two different outputs, and that is not okay. So I'm going to put no for this one, and I could just say, I think I'll say for a birthday, there could be more than one student. We could say September 7 has two outputs, but there's lots of different reasons. Okay, question 3, let f of x equals 2x minus 4 and evaluate f of 7. All right, please remember that f of x is just alerting us that it's a function. So we don't use that. We're just going to use the 2x minus 4. And in place of the x, we're going to put a 7. So I'm going to put 2 times 7 minus 4. 2 times 7 is 14, minus 4 is 10. All right, in the following graph, identify the domain and range. What I'm going to do for this one is I'm going to make myself a table because I think that will be easiest. This one looks like it's -3, 0, because I went to the left 3 and then stayed put. The next one, it stayed put and then it went down 2, so 0, -2. The next one is over 1, up 1, so it's going to be 1, 1. And then the last one is over 3, down 2, so it's to the right 3 and down 2. Okay, those are the only points that are listed. So we're not going to make like a something to something. Those are the only ones that can be included. So our domain will be -3, 0, 1, and 3 because they're all of my x values. And my range is all the y values, and there's only 4 of them. So we're just going to, actually there's only 3 of them. There's 0, -2, and 1. So that is my range. Okay, problem 5, read the following situations, then choose a situation that has a pattern different than the others, aka the alien. Explain why you chose the situation you did. All right, we're looking at patterns. You might see a few kind of shallow patterns, but we're looking for a deeper one, and I'm just going to kind of start listing things to see what's going on. All right, situation A. John started with $50 in his bank account. Each week he deposited $10. He put $10 in. So he first of all had $50, then he had $60, then 70, then 80, and so forth. He added 10 every single time. A pool starts out with 40,000 gallons in it. Because of everyone splashing, it loses 100 gallons each hour. So we start with 400,000, and then the next hour we're going to have 399,900, and then we're going to have 399,800. So every time we're losing 100. We're adding, we're losing. Okay, on this one, Janet started with 2 rabbits in her cage. Every 6 months, the rabbit population in the cage doubled. So it went from 2 to 4 to 6, to 8 to 16 to 32 and so forth. So it's multiplying by 2. It is increasing. Okay, and then the last one, Peter got a job at Jimmy John's and he earned $6.50 per hour. So first of all, he got $6.50. If he worked another hour, he'd get paid $13. For the next hour, he's going to get $19.50 and so forth. So every hour, it's adding $6.50 every time. Okay, so there's a couple that you could think of as the alien on this one. First of all, if you look at all of these are increasing except for B. So B could be my alien if my explanation was all of the others are increasing in pattern and that one happens to be losing. So that would be one alien. The second one that actually I thought of, all of these others are going up or down by a constant amount, and this one is actually being multiplied by something. So we could also think of C as being the alien. As long as you had a reason for wanting to think that that is an alien, you are okay. Okay, problem 6, use the fact that concert tickets cost $24 each to identify the independent and dependent variables. Remember, the independent is what you get to choose. You get to choose how many tickets you purchase. So our independent variable is going to be the number of tickets. Okay, what depends on the number of tickets? Well, the cost you're going to have to pay, so the total cost is going to depend on how many tickets you purchase. All right, my next one is to write a rule showing the relationship between the number of tickets you buy and the total amount of money you will spend on the tickets. And I'm just going to put right here, let's put an X and a Y. All right, my total cost, it's going to be $24 each, so I'm just going to put 24x. And one other thing that I'm going to do on this one, if I wanted to turn it into a function, we would just put f of x equals 24x. We're fancy. Okay, complete a table showing the amount of money you will spend for buying 1, 2, 4, and 10 tickets. Okay, so we'll have 1, 2, 4, and 10. If I bought one ticket, it will be $24. If I buy 2 tickets, it will be $48. If I buy 4 tickets, it will be $96. And if I buy 10 tickets, it will be $240. Okay, then it says to identify the domain and range, right? Technically, I really should, my table could have gone farther, so there's actually more to it than what's there. So for the domain, I'm going to think, what's the smallest number of tickets that I could buy? That would be 0. What's the largest number of tickets I could buy? Well, according to this example, it's 10. We could technically go to infinity, I suppose, because it didn't give us a limit on the number of tickets we're allowed to purchase. And then the range, what's the smallest amount of money that I would spend? Well, if I didn't buy any tickets, I wouldn't have to spend any money. And then according to this example, the largest amount that I'd have to pay would be $240. But again, technically, we might be able to go up to infinity because we actually could forever buy tickets, I guess, because they didn't tell me there was a limit. So this doesn't necessarily totally match the table unless I included everything that I could on the table. All right, number 7, analyzing graphs. Jeff walks home from his home to school. Halfway to school, he realizes that he forgot his algebra assignment, so he turns around, retrieves his assignment from home, and then heads back quickly to school. Graph time on the horizontal axis and speed on the vertical axis. So we're going to make a graph. We're going to put time on the horizontal. We're going to put speed on the vertical. And now we're just going to think about Jeff. Okay, he's walking from his home to school. So I'm guessing that he's walking at a steady pace. So I'm just going to keep him at a steady pace right here. So that's his speed. It's very nice and steady. Halfway to school, he realizes that he forgot his assignment. So he turns around, retrieves his assignment from home, and then heads quickly back to school. So I'm guessing that's what's going to happen on this one. When he turns around and figures out that he forgot his assignment, I'm guessing he's going to speed up. He's going to speed up, and then he's going to speed up, and then he's going to have to get home. So when he gets home, his speed's going to drop down to 0 probably because he's at home. He's looking for his assignment, and then he heads quickly back to school. So if he's heading quickly back to school, I'm going to kind of do something like this. And the reason I'm doing something like this, I'm guessing he ends up walking at a steady pace again, but it's a faster pace than we had down here because he's heading quickly back to school. So that should be something like what your graph looks like.